right, let's kick things off with a question that's, well, it's about as fundamental as it gets. What are you, really? Seriously. Are you a kind of machine? Just a collection of parts? Or are you maybe something more like a whirlpool? A stable pattern that holds its shape even though the water making it up is changing every single second. I mean, really think about that for a moment. The person you are right now and the person you were, say, 10 years ago, you share the same memories, the same identity, but are you made of the same stuff? The answer, when you dig into the biology, is kind of shocking. The wild thing is, from a biological standpoint, you're in a constant state of flux. The very atoms and molecules that make up your body are being swapped out all the time. Materially, you're almost a completely different person than you were a decade ago. And yet, there you are. Your form, your identity, it lasts. This isn't just a philosophical brain teaser. It's one of the deepest mysteries in biology. And this mystery, it's connected to all these other mind-bending questions. Like, how on earth does a salamander regrow a perfect leg? Not just a blob of cells, but a complex, working limb. Or how does an embryo, starting from just one cell, reliably build an entire organism, even when things get noisy or go a little bit wrong along the way? They're all different versions of the same puzzle. How does life hold itself together? Now, the answer you probably learned in school is DNA, the idea that our genes are basically a blueprint, a complete set of instructions that just gets executed step by step. But as we're about to find out, that metaphor, well, it's useful, but it really starts to fall apart when you look at how flexible and resilient life actually is. And this quote from the paper we're looking at just nails the problem. A rigid blueprint is fragile, right? If you scratch the architectural plan, the building is going to have a flaw. But living things aren't like that. You can mess with an embryo, you can cut off a salamander's leg, and they have this incredible, almost magical ability to get back on track and reach their target. Life isn't brittle, like a computer program, it's robust. This table really lays it all out, doesn't it? On one side, you've got the old school blueprint idea. It's rigid, it's top-down, like a general telling an army exactly what to do. But on the other side, you have what we actually see in biology, which is flexible, adaptive, and coordinated from the bottom up. It's more like a flock of birds turning in unison, or a jazz band improvising together. So, this leaves us with a huge question. If there's no master blueprint, no central boss calling all the shots, then what is guiding everything? What makes sure a liver cell behaves like a liver cell, and what tells a salamander to grow back a leg instead of, say, an eyeball? Well, the answer might lie in this absolutely fascinating idea called constraint closure, and it completely changes the game. It suggests that an organism isn't something that's built like a house. It's something that is constantly building and rebuilding itself. A really great way to get your head around this is to think of that orchestra with no conductor. The musicians aren't just blindly playing their sheet music. No way. They're listening to each other constantly. They're adjusting their own tempo, their volume, all based on what's happening around them. And through all those local interactions, a coherent, beautiful piece of music emerges. The music they create then guides what they play next. The system literally organizes itself. Okay, to really get how this works, we need to understand one key word: constraint. And it's not what you might think. A constraint isn't a command. It's just a physical reality that limits what can happen. Think about a river flowing through a canyon. The canyon walls constrain the river, right? They don't tell the river where to go. They just make it impossible for it to go anywhere else. And in our bodies, these kinds of constraints are literally everywhere. They're the chemical signals zipping between cells, the physical pushing and pulling in our tissues, the tiny electrical voltages across membranes, and even the structural scaffolding that holds all our cells together. And this is where it all comes together. The big idea: constraint closure. It's this powerful, circular process where the network of constraints, all those signals and forces, is created and maintained by the very activity that it's constraining. The cells create their environment, and that environment, in turn, tells the cells how to behave. It's a perfect feedback loop. The system literally pulls itself up by its own bootstraps. So we can kind of break this down into a few steps. First, you have cells interacting with their neighbors, creating local constraints. Then those constraints start to spread through the system, connecting everything together. After a while, this whole global network becomes stable and self-reinforcing. And once that happens, this large-scale organization starts to boss around the very cells that created it. It's a two-way street between the parts and the whole. So what's the big deal? Why does this all matter? Well, this whole idea of constraint closure isn't just abstract theory. It gives us a brand new and really powerful way to look at some of the most fundamental processes in all of biology: how we develop, how we heal, and even how we get sick. This table really makes the shift in thinking pop. So, development. The old view is that it's like running a computer program. The new view, it's more like a marble rolling to the bottom of a bowl. The system just naturally settles into a stable state, what scientists call an attractor. Regeneration, then, isn't about rerunning the program. It's just that the marble got knocked up the side of the bowl by an injury, and it naturally rolls back to its stable spot. And cancer? Wow. This new view just flips the script on cancer entirely. Exactly. From this new perspective, cancer isn't just about bad cells with messed up genes. It's a failure of the system. It's a breakdown of that top-down coordination. When that regulatory closure is lost, the constraints that keep all the cells working for the good of the whole, they just disappear. And that lets individual cells go rogue, reverting to a more primitive, selfish state where all they do is multiply. And this is not just an academic argument. This way of thinking has huge, profound implications for how we might approach medicine in the future, and even for how we understand what we are. I mean, just imagine, instead of therapies that just try to kill cancer cells, what if we had therapies that aim to restore the system-level coordination that keeps them in line? Or imagine diagnostic tools that could spot the early signs of a system becoming unstable, that loss of constraint closure, long before a disease actually shows up. For regeneration, the goal wouldn't be to just inject some cells, but to recreate the conditions that let the body tap into its own incredible self-organizing power to heal. And look, this isn't just some hand-wavy philosophical idea. It's a real, testable scientific theory. It makes predictions. For instance, it predicts that an animal's ability to regenerate should be directly linked to how well connected its internal communication networks are. It predicts that we should be able to measure the system's stability fraying before a disease strikes. And maybe the most radical prediction of all, that we might be able to tame cancerous cells, not just kill them, by putting them back into an environment with strong, healthy system-level constraints. And this brings us right back around to that first big question we started with. What are you? If this view is right, then an individual isn't their collection of material parts. You aren't your cells any more than a whirlpool is the water. You are the process. You're the self-maintaining pattern, that organizational whirlpool that has kept itself going through time, constantly rebuilding itself with new materials. So I'll leave you with this to chew on. The next time you look in the mirror, are you looking at a static object, a machine made of flesh and bone? Or are you watching a dynamic, self-organizing process in action, a coherent pattern that has miraculously maintained its own existence against all odds for your entire life? It's a pretty fundamental shift in what it means to be alive.